Okay, this is Dr. Wang again, and today I'm going to talk a little bit to you about hypothesis testing. What it is, when would you want to use it, and what does it get you? You probably have already watched the confidence interval construction, which gives you an actual interval which bounds the population, say, mean or difference of two means of your real interest. Another way of estimating the population parameter, like the population mean and so on, is to do a hypothesis testing. You perform a small sampling, you have a sample mean, X bar, or difference of two means. You want to test, can I say the actual population mean is as much as this, or it's less, or what? So here's a standard form of stating or setting up a hypothesis testing. This is for a single mean, okay? You always have two hypotheses. H0 denotes the null hypothesis. H1 denotes the alternate hypothesis. The null, remember this for the rest of your life, you're going to be engaged in this. The null hypothesis is always equality. Something, the true mean equal to some number. Never a inequality or not equal. Never, never, never. But the alternate hypothesis, you can state one of three ways. Oops, I'm trying to cover this up. Either you want to test, can the actual mean not equal to whatever number? Or can the actual mean be actually a little larger than whatever number you want to test? Or can it actually be less? Now, which one do you choose? Can you just choose any one of these randomly of the three? No. You want to choose, first of all, that's actually of your interest. Second of all, depending on the number you actually put here and the sample result you actually get, which I'll go over in a little while. For instance, you were doing EPA sampling. Again, you're cleaning up pollution. Of course, you want your after pollution to be less. And so you wanted to say, hey, can my clean up reduction of pollution? They say it had to be at least so and so. You want to test the appropriate number. So this is a single population mean. What if you want to test the before and after, improved process before and after? Did I actually increase the lifetime of engine part? Did I actually reduce the pollution level? Did I actually increase the test results? Or whatever thing. So you're going to involve in two different samples. So here is the statement. How you set up the hypothesis testing for comparing the difference of two means. Remember the null hypothesis is always equality. So you want to say, can the true difference between the population mean mu1 minus mu2 be some number? Or, not or, then the alternate hypothesis is one of the three, not three, only one of the three. Can the difference not equal to the number? Remember, these numbers here between H and H has to be the same number numerically. Or you test, is a difference larger than some number, or is a difference smaller than some number. You only state one of these three alternate hypotheses. Now, the way hypothesis testing works is that you use your sample result, the X bars, the S, and the N, to do the testing. If the result says you had to reject H null, which is this, then your only choice is to accept H1. That doesn't mean you agree with H1, but it just means you don't have enough data to support the claim hypothesis stated here. Therefore, you have to accept H1, even if you don't like it. It's like this. You go for a presidential election. I remember when a while back, say it was between Clinton and Bush. I forget. Anyway, if you don't want to vote for Clinton, but you don't want to vote the other guy also, but you really don't want to vote for Clinton more, so you have to vote. If you want to vote somebody, you got to vote the other guy. Doesn't mean you're really for the other guy. So if you reject this, you have to accept this. If you accept this, you have to reject this. You can't accept both. Even though you like, oh, I like this one better, we can retest. So here is so hypothesis just means data support. So what do you say in English after you perform this hypothesis testing in your engineering report? Suppose you have some testing you did which says you have to accept H naught. Then you say sampling data supports the hypothesis that the population mean can be as much as 38.5 months. Say you're testing the longevity of some parts. Or data does not support the claim that the engine parts longevity is this. Rather, it supports the claim that it's larger than, suppose this is your thing, you accept this, or smaller, whatever the H1 you stated. So again, the English equivalent you want to put in your report based on your hypothesis is that sampling data supports a claim that. Or if a weakly support, you say, here's where we had to use wishy-washy words. Here are the wishy-washy words in engineering reports. Appear to suggest, strongly suggest, weakly suggest, does not seem to support, strongly support. You indicate this to show on the statistic table how far the computed data, which I show you, actually lies on your acceptance region. So here's the idea of hypothesis testing. Again, we use either Z table or T table. So what that means is that area under the curve is 100%. I blocked this out. We're doing 95% confidence level. If you're doing the not equal, then you put 2.5% over here, area here. You put 2.5% here. Then the area inside here in the middle part will be 95%. So this will be 95%. So what this means is that if, based on your testing, you want to claim the true mean based on it could be something like this, then you're going to compute something, which I'll show you later. Then that something you compute will fall most likely in the 95% area if that equality holds. It will occur here. So in this area here, I'm going to call this OK region. In this whole area, it's OK region. It's 95% right here. If you compute it, we call computed statistics, falls within that. If it falls either here or here, I call that the forbidden region. Forbidden, not okay. It always reminds me the planet, the forbidden planet. It's one of the planet, whatever sci-fi thing here. This is a forbidden area. It's right here and right here. Depending on where the testing larger than, it will probably fall here. If it's less than, it will fall here. When it falls here, forbidden, you reject H null. Reject H null, meaning you have null hypothesis cannot be true, whatever the equality. If your computed statistic falls in the OK region, you say, yes, I will accept the H null. So I'll give you an example. I will give you a part 2 as an example. So what is it, for instance, if you say, oh, I want to test the aspirin level of the tablet. Oh, I computed to be 326.5 milligram, but I really need to bottle at 325. Even though my sample result have a sample mean of 326.5 milligram per pill, can I still claim the actual mean of all my pill can be 325, even though my sample mean is higher? Well, you go ahead and say mu equal to, then you erect hypothesis then. So the sample here is 326, I forgot, say 9 milligram per pill. Okay, and the n is say 35, let's just say. Okay, but I'm really interested, I need to keep a 325 because that's what I claim. That's what the FDA will accept. So I erect my H null. Can my mu actually be 325 milligram? Now, if you say, suppose if it's not equal, then you have to scrap the whole thing. Let's just suppose you're not interested whether it's larger than or equal to. Then your alternate, then you say I want to do is 325 or not equal. Because if it's not larger than or equal to, I got to improve my purification process or something. But suppose it is better to be under than over. Let's just suppose because of overdose or something. Then what you want to do is H null, then I'm still want to see, can it be like this? Now, since your actual thing is 326, then your alternate has to be larger than 325 because this number is larger than that. You cannot say less. But if this number is 323, then your alternate can be less. So that's a restriction. Now, so you're going to compute something, And you're going to look in this table and see, since you're doing not equal, this is not equal. So it could be here or it could be here. So you wanted to, we're doing 95% level. We always do 95 because that's what industry accepted confidence level testing. Then if you're doing not equal, it could be more or less. Then you split 2.5% area here, 2.5% area here. If you're doing larger, then you're interested in finding the value that leaves all of 5% to the right. If you're doing smaller, or if the situation warrants it, then you want to put all the 5% to the left over here. You're still doing 95%. So doing not equal is called two-tailed hypothesis testing because you have larger than or smaller than. Doing larger than is called one-tail because you're just concerned with here. Or smaller than is one-tail. So doing one-tail test, you put all 5%. Again, do you use t-table or z-table? We talked about this in the previous confidence interval presentation. If your n is larger than 30, you use a z-table. If your n is smaller than 30, you use a t-table. So I will stop here. This is the introduction to what is hypothesis testing. And next video, I will go ahead and present a couple examples for you.